All right, today we're going to be looking at section 6.1 and it's trig functions and identities. I'm actually not on the first page, so let me get there so we can get this from the beginning. Okay, so we're going to start out solving right triangles. These will be right triangles with angles less than 90. The angles will be denoted with Greek alphabet. So you will see this symbol almost looks like an A, it's alpha. Looks like what a capital B is beta. The Y is gamma. Looks like a zero with the line through it is theta. And then phi. These are the ones that we're going to be using most often. The most prominent one is theta. Given a right triangle, we can solve it with trigonometry. So we used to solve them with Pythagorean's theorem. Now we can solve them with trigonometry. So you will have a right triangle. One of the angles might be labeled such as theta. Depending on where that theta is, you will be able to denote your sides. So the side right across, opposite side, is what we call opposite, the one that's right across. The side that touches it is called the adjacent, and the long side opposite of the right triangle or the right angle is the hypotenuse. The 6 sine functions that we will be learning are sine, cosine, tangent, cosecant, secant, and cotangent. They're labeled right across from their reciprocal function. So the reciprocal of sine is cosecant, the reciprocal of cosine is secant, the reciprocal of tangent is cotangent. Here again you can kind of see the opposite, the adjacent, and the hypotenuse labeled. Sine, whenever we start using these to solve right triangles, sine of the given angle is equal to the opposite side over the hypotenuse. Cosine is equal to the adjacent side over hypotenuse, and tangent is equal to the opposite side over adjacent. So there's a lot going on here, a lot to know. Here is this in the table. So you have the 6 trig functions and their proportional relationships based on the right triangle given. Now, all of this, if you're in my class, can also be found in the trig cheat sheet. So let me show you. From within Blackboard, you go to the video section, and then I have a trig cheat sheet for you. So the trig cheat sheet, I'm going to zoom in a little bit. It's really like a 4-page document that I have condensed down to 2 pages, 1 page front and back. But those 6 trig functions are here, showing you opposite over hypotenuse, so forth and so on. And then we will also be using the unit circle, which will introduce that, where you learn the value of sine is the y coordinate when you have an ordered pair. The value of cosine would be the x coordinate, and then tangent is the y over x. And then, as I was mentioning, the reciprocal, if you just do 1 over those numbers, you get these reciprocal functions. You also kind of see some of those up here, tangent and cotangent. So basically, one thing you can pick up here is that every trig function, every single one of these, can be written in terms of sine or cosine. So, for example, sine and cosine are the basic trig functions. If I want to write tangent, notice that tangent is equal to sine divided by cosine. And then vice versa, cotangent, which is the reciprocal, can be written as cosine over sine. And then these reciprocal identities across, cosecant can be written, where's cosecant right here, as 1 over sine. And then secant can be written as 1 over cosine. So all 6 of these functions can be written in terms of sine and cosine. That's going to be important to know later. But all the information that you'll see in the text is also in this trig cheat sheet. We're going to be using cofunctions. This has them in radians. The book is going to show you them in degrees, but it's all the same. And then if I scroll down a little bit more, we get the unit circle, okay, which I have a separate document with the unit circle in it. We're going to be using inverse properties here, just a lot of things that we'll learn throughout here. So this Trig cheat sheet is here in Blackboard, but again, all of this information is in the book as well. Hold on, before I go, let me also show you the unit circle here. So again, in the videos folder, right below chapter 5, we have the unit circle. This one is completely filled in with all of the positive trig functions according to their quadrant. So all of that is there in Blackboard for you, or you can find it online. So you'll be given a right triangle. First thing we're going to want to do is label the trig functions according to opposite hypotenuse and adjacent sides. You have the reciprocal functions here. Again, me mentioning that each function can be written in terms of sine or cosine. And then you have several examples that they go through and show you. So it'll get a little bit more involved. Sometimes they'll give you a full right triangle. Sometimes they'll give you a missing side, and you might either have to do Pythagorean theorem, which you're kind of seeing here, to find a missing side, or you can use the trig identities. So depending on what type of right triangle you have, if you have a 45, 45, 90, this is matching up with one of the exact angles from a unit circle. But even so, you can still find it using trig. So function values of acute. So this one talks about degrees, minutes, second form. We don't actually see any problems in this section with degrees, minutes, seconds, but we will see them in the next section. So let me talk about it. Degrees, minutes, seconds is a notation just from decimal degree form. So decimal degree form is just like a regular degree with a decimal number. Degrees, minutes, second is a different form. You can almost think of it like hours, minutes, seconds. So to convert from one to the other, so let's say that we had, let me see, what do they start you out with? Degrees, minutes, seconds. So is this converting to degree decimal form? Okay, so what you will do, think about this as seconds. How many seconds in a minute? You divide by 60, and then once you convert to minutes, you can figure out how many minutes in an hour. There's 60, so you'll be dividing each of these by 60. That's what they're showing you here, but we'll do it in application. So what they do is they divide by 60 and they combine it with the next term because they converted the seconds to minutes. And then once you do that, you divide this by 60, and then you'll get the decimal form, and they round the 2 decimal places. If you were going to expand this out, you would divide this by 60, take the whole number and write that down, and then take that decimal, divide by 60, and then you get your seconds to 2 decimal places. So going forward and backwards, which I'll show you that probably in section 6.2 when we actually use it. And the calculator can also convert to degrees, minutes, seconds for you. But again, we don't see it. We don't see a problem like that in this section, but we will in section 6.2. Other than the right triangle, we will go over these cofunction identities. So what this is saying is that if you have an angle measuring less than 90, so let's just say that this was 50. So let's say I want to know what the sine of 50 is. The sine of 50 would be the same as cosine of 90 minus 50, which means 40. So another way to think about this is that these two angles, if they add up to be 90, the theta and the 90 minus theta, then they're called cofunction. If the sum of those are 90. And you can find the exact value just knowing a few terms. So they're showing you the relationship here. If you have sine of 72, that's the same thing as cosine of 18. They're both equal here. And then vice versa, cosine of 72 equals to the sine of 18, which equals this. So if you add those two numbers up, it equals 18. It only does that with its counterparts. So sine and cosine, tangent and cotangent, secant and cosecant. Those are the ones that match. That's why they're directly across from each other. And it looks like I don't have another page. So that might be all the information that we cover here in Chapter 6, Section 1. So information overload, we're going to jump over to My Math Lab and start working some of these problems out.